Solve each equation. These are all exponential equations. We're going to use the same strategy we used before. Can we get them to be the same base? In these questions, though, they've introduced some radicals. So we also have to go back to grade 11 and know that we can change a square root to a power of a half, or an exponent of a half, a cube root to an exponent of a third. So in this case, we're going to have 2 to the x equals, and if I'm looking on my powers chart, 2 is the smallest power that we have, so we're going to have to try to change everything here to powers of 2. Well, I can change 8 to 2 cubed. And the cube root of 2, so any square root will be 1/2, cube root will be an exponent of 1/3, and so on. So this is what we get. And now we have another exponent rule, which says if my bases are the same and I'm multiplying 2 powers with the bases the same, what do I do with the exponents? What do you do if you had 3 cubed times 3 squared? Is that 3 to the 6? Is that 3 to the 1? Is that 3 to the 5? Well, if we again think about what does this mean? 3 times 3 times 3, and this means 3 times 3. We would get 3 to the 5. So what's the shortcut? Instead of having to write them all out, you just need to add the exponents. I mean, you can write them out if you want, but adding is sure nicer when you have this. But if you would like to write out 300 threes, and then write out 200 threes, and then count them all up and find out there's 500 of them, you can do that. But I would suggest adding them. And so here, even though we have fractions, that idea stays the same. We're going to add 3 plus 1/3. Well, in order to add fractions, I'm going to change that 3 to 9 over 3, so I have a common denominator. And then I can write both as a single power with a base of 2. And because the powers are the same, I mean not the same, but have the same base, in order for these to be equal, x has to be 10/3. Part B, looking at those numbers, 125 and 625. So the first thing you have to decide is how can we write these as the same base? 125 is 5 cubed. $625, I don't even, is 5 to the power of 4. So now what does it mean if I have a square root of 5 cubed? Okay? Well, that means that I have 5 cubed to the 1/2. And over here, I have 5 to the 4 to the 1/3. We've already talked about this, a power to a power, using our exponent laws and our exponent rules. That's 5 to the 4/3. And on this side, we will have 5 to the 3/2. And then we still have a power to another exponent. So what does this mean? We multiply those. And we finally have both sides as a power of base 5. Again, I like to take out a different color pen, maybe a highlighter. Put a box around those so that you see 5 to the green box equals 5 to the green box. So whatever's in those green boxes has to be the same in order for this to work. That means that 3x plus 3/2 has to equal 4/3. And then we get a simple equation with just solving for x. So I'll move my x all by itself on one side. How do you subtract fractions? Have to get a common denominator. This is 8/6, this is 9/6. 8/6 minus 9/6 will be negative 1/6. Divide both sides by 3, which is the same as multiplying by 1/3. And we get x is equal to negative 1/18. Questions for practice? 9 and 10.